Okay, hello both to the online participants and the people here in Tampere office of Solita. There's good amount of us in both teams and few people as well on the live session. Big welcome to all to this event where we focus on circular economy and material efficiency and AI. AI meaning artificial intelligence and machine learning data science solutions. This event is hosted by Solita and part of Business Tampere's Intelligent Organization event series. My name is Mika Ruohonen. I'm the head of data science, AI and analytics here at Solita. And basically responsible for the solutions and consultancy we do on those fields. Firstly, we have a few words about Solita. Then we open up a bit why we have selected this team, circular economy, material efficiency, and AI, and then move on to the actual agenda. And I will be presenting the speakers soon. But as said, a few words about Solita. Solita is a fast-growing digital transformation company driven by data, analytics, and AI, and human insight. We have around 1,500 professionals in the Nordics, and our services range from strategic consulting, service design, software development, data and machine learning engineering, AI analytics, connectivity, and managed cloud services. So wide range of different digital IT analytics services. Our cross-functional teams are ready to help organizations with even the most complex data and AI challenges. But that's enough about Solita. More information can be found from solita.fi. And then moving on to the actual team. One can ask that why did we choose at this time, especially succeeding with AI in circular economy and material efficiency as the theme of this event? Well, the obvious part is that which our other guest speakers will be opening up in the coming presentations is that circular economy in the current global situation and the global challenges regarding climate change, biodiversity loss, etc., are really topical and therefore really topics we want to also as Solita keep raise up and are meaningful for all of our professionals. We are working on multiple projects on this field at the moment, and therefore we felt that this is a good angle to the AI discussion. In short, circular economy refers to this kind of a production and consumption framework which aims to keep products and materials in circulation, either as products or then as long as possible, or then when they can't be anymore used, then as recycled materials or sub-products. But our following speakers will be opening up more on the topic and the opening up what circular economy means. Then the question, of course, is that why we selected AI as an angle to this event. And the reason is that Solita is a company which is focusing a lot on AI, artificial intelligence, machine learning development and consultancy. We have a long experience from developing in-production solutions, impactful AI solutions and applications, and supporting organizations in different phases of their journey. Some are more mature, some are starting and taking the first steps. So basically, building awareness all the way to this kind of a consultancy training, which builds awareness to the large-scale sustainable development and adoption of AI solutions. And we have been also privileged to do this in the context of circular economy, especially, for example, in manufacturing industry and with manufacturing companies like KONE in the areas of predictive maintenance, which of course aims to increase the life cycle or the length those products are utilized. and therefore also reduce this kind of a need for new products and reduce maintenance-related travel and transportation costs. The other area where we have supported companies in this field is this kind of a demand-driven production and sales. So producing solutions only to the need at hand, which aims to reduce waste and costs related to that. For example, with companies like Amer Sports. And furthermore, we have been supporting, for example, waste sorting companies with building solutions to utilize AI and computer vision to automate large-scale processing of waste and sorting of waste, as few examples. And that's the reason why we have this AI angle, especially in this event. Then moving on, let's have a look on our guest speakers. Trying to change the slide now. After these introductions session or part of the event, we'll have Aki Finnair, Director of Circular Economy from Motiva, discussing or presenting us a presentation about circular economy and AI. After that, our own AI strategist, Kartik Singha, will be going through different potential use cases in different industries and areas for AI in the context of circular economy. And then we move on to our company or manufacturer presentation, which we get from Tana. And the Vice President Services at Smart Sites, Teemu Lintula, will be telling us how AI can play an important role in Tana's roadmap and plans. And as the last thing, our machine learning architect, Jokke Ruokolainen, will be explaining this kind of a typical AI DevOps lifecycle and using one of our case studies projects in the field of waste sorting as an example to run through that process, all the way from the starting of the project and the ideation to this kind of a deployment and operations. And all that is done in approximately 2 hours. Before going to the Motiva presentation, some practicalities. All questions are welcome. On those online, please use the Teams chat functionality to post the questions. We'll be covering those and selecting few of those at the end of each presentation. And the live session here at Tampere, keep your questions in mind, and we'll be asking them after each presentation if you have any questions for the presenters. Now it's time to then give the stage to first presenter, which is Aki from Motiva. Welcome, Aki.
Thank you, Mikael. Okay, fine. So thanks for Solita for inviting me to give this speech about the circular economy and AI. I'm Aki Finnair, and I work as a director of circular economy in Motiva. Motiva is a state-owned sustainable development company. We are mainly known about our work in energy efficiency area, but we have also a long history of working in circular economy and material efficiency, where we have, for example, introduced different kind of methodology to do audits for companies in terms of material efficiency, and we also are taking care of material efficiency. Let me see. I forgot the word. So we are working in food sector in terms of material efficiency. So we are state-owned company. So most of our clients are agencies and ministries, but we also work with private companies, we work with communities and cities. So my perspective from circular economies is somehow from the public sector point of view, but in my speech I will express what are the possibilities, but also what is limiting the development of circular economy, and how digital solutions can boost circular economy in the future. So that's my focus in my speech. Let me see what direction I need to go. Is there my there? So I'm not telling what Kartik will tell to you. So Kartik is a specialist for that. Yeah, but why circular economy is important? So some of you may be familiar with this picture from Ellen MacArthur Foundation, and Mikael also referred to this picture. Circular economy aims to keep all the energy and materials extracted from the earth crust in circulating in our economy, but it's not only focusing on those finite materials from earth crust. It also look at those materials from what we get from the nature. For example, wood, food, and that kind of materials. So one key thing in circular economy is that we extend the life cycle of products. So we don't just use them and then dump them in the landfill. So the key is that the products will be designed from the beginning so that they can be reused, or they can be modified, that the life cycle will be longer. Or if you have to get the life cycle ends and then you have to put that product aside, then you can utilize the materials of the product as easily as possible to create new products. So we limit the amount of materials going to the landfill or which is incinerated to create energy. So this is very important. We have limited resources on Earth, and also this will limit carbon dioxide emissions. But you need to be careful if you address that circular economy always lowers the emissions. That is not the case. But when the processes are designed well, circular economy also reduces carbon dioxide emissions. Then one aspect for the circular economy is also the market potential. So here is some numbers which we have collected from various sources. The potential in Finland, we construct quite a lot of buildings every year, but also we get a lot of construction waste and demolition waste. So there is some materials which can be used again to create new construction products. Then we use a lot of ICT products, phones, TVs, laptops, and we create ICT waste, electrical waste, and that waste, it has very expensive ingredients, materials in them. So how can we utilize that waste as a raw material for new electronic equipments? That's a question, and I know that there's a lot of companies trying to solve this question. Then there's also textiles. We use a lot of textiles, and quite a lot of this textile of these textiles can be reused in some other form, like making carpets. In history, people have made carpets from the textiles like clothes. Now we have to make this in industrial level, and we have also examples in Finland from that area. But when we look at the European level and global level, the volumes they are vast, and there is a lot of unused resources also in a waste and all in products which have already been produced, and they can be used as a new raw material in the future. But then how digitalization come into picture? We made a survey for the Ministry of Economic Affairs and Employment of Finland, together with Accenture, Gaia Consulting, and Solita. And the name of the survey and the report is Digitalization and Ecosystems of the Circular Economy. So you can find the report from the internet. I added also the link, so when you get the material, you can also use the link. So I refer to that report, and the report consisted of current state analysis. Then it also consists of a target architecture for data in circular economy, and also measures how to get in that point that this kind of a target architecture can be built and utilized. But here are some findings from the current state report. So the report says that circular economy requires sharing of a lot of data and materials and products, product information between different organizations, also from different industrial areas to operate. And what are the challenges? That the data and information is at the moment very scattered, fragmented, and all information systems are fragmented. And the data is it's not centralized, so it's not collected in databases quite well. So it can be in one laptop or in Excel, and the other Excel, and it's not collected, so it can be used from data science perspective. Then one problem is what we have discovered in circular economy, that there's a lack of trust between actors. So actors they don't recognize what is the business critical information, and what is the information that can be shared, and then that way boost the circular economy. So they share information about their waste for their side streams, and then another company can see that there is a raw material for us. Let's contact that company and then make business with them. Then there is also a skill gap in Finland and globally. So there is certain principles in circular economy. There is definitely certain principles also in digital technology, and combining those knowledges together, there is a skill gap in Finland and in globally. So that need to be taken care of and find a solution for that. But luckily in Finland we have a lot of possibilities in this area. We have qualifications to be the forerunner in this area in the world. we have a positive atmosphere, an attitude towards innovations, circular economy, and digital technologies, and that's one reason why we can be a forerunners, and I think that we can find the common understanding how we will collect the information and share the information in the future. So we have a good ground to create create this kind of interoperable architecture and data models for circular economy. Next, I would like to share you some of the categories related to data in circular economy. So there is a lot of information you need to collect from materials and raw materials. What are the chemical and physical characteristics of those materials? Then you need to know production data, life cycle data, how many users, for example, have used certain ICT equipment. Then the usage and consumption data, performance data, and so on. Also, value chain data is important. But there's a lot of different kind of information related to circular economy, products in different value chains, which are also needed in when these products and materials circulate in back to the different production phases in the value chain. And by collecting this information, it allows to industries, for example, to improve the efficiency of their operations and production, and it will increase productivity and also responsibility of different operations. But to implement this data for circular economy, you need to understand complex value chains and networks, resource flows and cycles, and also the value and environmental impact of using those resources. So you can imagine that this is quite a complex field of data and data-driven circular economy. So we see that to enable this to work and enable circular economy to happen, digitalization and utilizing the data is very, very important, and it will also lower the costs, but also boost operations and businesses of different companies when they are designing, building, and producing circular economy compatible products. Okay, so there was those data points, and actually I would like to add that many of those points are so that there is also potential for modern digital technologies like machine learning. For example, we have been working in area of construction and demolition at the moment. So there is a need to understand what kind of materials are in certain buildings when it's demolished. So the materials can found a new home, new building where those materials are used. So machine learning can be used to create those pre-demolition audits, for example, or help to make them, and also collecting many of those data, material data, the physical data of different materials, for example, concrete pillars or stuff like that. Different kind of technologies can be used which include machine learning and AI, like computer vision or picture recognition and stuff like that. So there is a potential for modern digital technologies. And when we arrived here, I came by with Kartik by a car from Jyväskylä, and we were discussing about the forest industry. So in circular economy, the materials are scattered around Finland, for example. But it's similar than, for example, in forest industry. The forests which are harvested and wood is collected, they are scattered around certain area around the pulp mill, for example. And there is a lot of technology in harvesters. There's technology in those trucks collecting the wood from the forest. They use they know the location of those piles of wood. Then there is a different kind of technology used when the wood arrives to the pulp mill. So there is also this computer vision used and so on. So the technologies are there. Now we need to find a way to utilize and implement the technology in circular economy area. We find and choose the correct technologies. So the limitations are still that there is no existing efficient way to collect, administer, share, and utilize circular economy related data. And the data, when it's not collected, it can be, for example, then used, for example, for decision making. So the report addressed that we need a common target architecture and data models to collect the information needed, and then also find a common way to collect the data between industries and companies, and that way the optimal value of those materials will be maintained. So the report proposed target architecture. I won't go to this detail. You can see it from the report, but I pinpoint one possibility when we have this kind of common architecture and data models. The data is correctly collect, and the amount of data and amount of quality data is available. Then, for example, trading of these circular economy products and services, it's much easier with digital applications. And then in the study, we went that far that there is an idea of material trade application which has 4 steps. 4 steps, quite small steps to make it happen. That as you read it, it's small steps that you can exchange materials. But of course, there is also possibility for modern digital technologies. So in this new way of thinking and doing the material trade, the buyer and seller announces one trading application into the system, and then the trading application searches for trades that meet the marginal conditions of the announcement. And quite often in circular economy, the materials need to be upcycled, for example. They need to modify, they need to be sorted. So additional actors can come into play and offer those services. And then when they that match happens, the trade application records the deal as an initially created and then enables the payment transaction for the deal to be completed. And the fourth phase is that then these parties will agree the deal if there is some things that are that need to be, for example, be agreed, like business secrets, different timetables, so on. So they can be agreed across the parties. And also if it needs, for example, the product needs to be transported, they can add the logistics service in this picture. And according to the study, how this how this difference from the target from the current state. Nowadays there is a lot of marketplaces where you can sell and buy materials, but they are quite often in individual places. They are independently owned, and this the trading is only happening in one platform. But in this proposed way, the trading can happen in multiple trading applications, and that's how it's like a connected distribution network. Also, the data models quite often reflect the organizations which have made them. So now this proposes that there will be a universal data model used, so the data is more easily, for example, written with different digital applications. And for example, GaiaX, this kind of a universal data model is just being created. And also this report addressed that this will lower the financial problems or financial operators' risk to invest in circular economy. So nowadays it's difficult for the investing companies to see the business value in untested field of business, and this will help them to invest, and public sector only can act as a partial financer as buying these circular economy products. So private money is also needed to make circular economy happen. I have almost used all of my time. I will briefly describe what public sector is doing to make this happen. So in construction industry, for example, this kind of a database for dismantled materials and construction waste has been designed. There was a pre-study last year. Solita was also involved, and Moti was also involved in this study. So this kind of database will be realized. It will be built this year and during this year and next year, and this will harmonize the data collection from the construction industry or construction area. So it's idea that pre-demolition audits will be made about the demolished buildings or buildings which will be demolished, and the data is stored in this database. And when for example the building is demolished, then those transfer documents from construction and demolition waste will be saved inside the database, and also give the data how much of this material audited is realized and how much is transferred to the further processing. But of course, because this is public database, this also supports construction and demolition waste statistics. So Ministry of Environment and Suomen ympäristökeskus, they will get statistics how much construction waste is generated in Finland every year. But there, when designing this database, there was also view that the data should be available for companies to use. So there is this fourth way of transporting the data to online reuse and landmass markets. So there will be a different kind of ways to utilize the data also for business use, which is stored in the database. Here is some more detailed picture how the data is handled, but I will jump over it. In Motiva, we have been working, as I said, in construction industry and construction area and demolition area at the moment. A couple of years back, we created a concept for circular economy platform ecosystem, and we have now tested this idea in different projects with customers in Tampere area and also in Helsinki, where we collect the data from demolished buildings or buildings which will be demolished in the future. And we are testing what kind of data needs different actors have, and what is the good way to transfer the data between actors. And of course, we try to lower the boundaries. So we have noticed also in these projects that the trust is very important in this area, exchanging data between different actors. But this the idea of this platform ecosystem is that the data about the different building materials available can be shared between different, for example, different marketplaces. So it's not only available, for example, in Materiaalitori. So it can be presented also in private marketplaces. So as a conclusion, this conclusion relates to construction area, but as a conclusion, as a whole, circular economy has woken up. There's more and more companies coming in this area. But at the moment, those decentralized material flows, they don't find the users very well. So the data need to be collected and also utilized to find those buyers and sellers of different materials. Of course, the price and availability of circular economy resources is changing while the environmental regulations is tightening. So of course that's there's more and more materials coming to circulate in our economy. So that's also the way that circular use cases become more cost effective. For example, at the moment, 1 ton of concrete, it's €5. The value will be higher, I suppose, in the near future. So and the circular economy, it's strategic priority for many companies at the moment. And as I told, there's a new innovations, new startups, new companies, and also old companies. They are trying to find their place in circular economy. So you should put focus on circular economy and also be involved in the everyday life of those companies creating these circular economy businesses, because they need data, they need to collect data, they need the data to build very well operating systems and processes, but they also need the information to find the markets. So there is also room for data science in this circular economy field. Thank you.
Thank you, Aki. So some work to be done on the data side and architecture side. There was one question regarding actually to the construction industry, which you also used as an example. There's a question that, do you know of real world projects that test or implement AI in the construction or demolition field? The person asking the questions, they are working on using computer vision for reusing and remanufacturing cobblestones.
Okay. I have only actually heard that there's, for example, sorting of materials. There is a computer vision used, and so there is probably Kartik will give us some examples, but there is quite few of them at the moment.
Yeah.
In this Helsinki case, we actually gave the data to a student from Aalto University, and he tested how pre-demolition audit data can be used to create machine learning algorithms that predict what kind of or how much different materials are coming from different buildings with different age, or how many levels the building has. So and he was quite excited about the results. So it's possible to use machine learning algorithms to make this kind of work, and then an expert will audit the results, and this data can be used for further use, and also combine the data from what is the actual outcome when the building is demolished.
Thank you. Yeah, definitely. And Kartik will be opening up other use case areas, but I think the one really concrete is that this kind of a computer vision to sort different kind of materials.
Yeah.
So, but of course, a lot of others as well. But really big thanks. Any other questions from the audience here, or shall we move on to the next? I think we can move on. We can take a few questions also at the end of the whole event. So next we'll have Kartik Cynthia from Solita, AI strategist, and opening up some potential use case areas of AI in circular economy. Good, thanks.
Thank you, Mikko. Yeah, thanks everyone for joining us today. So the title of my talk is to open up some potential use cases which provide you a glimpse of how AI has been used in industry with the focus of circular economy. But this is no way kind of an exhaustive or a list, but more so borrowed from the same Ellen MacArthur Foundation. And I think I would again quote back Aki saying that the circular economy has woken up, and it has woken up in a way that people are more profoundly using different methodologies of AI, but probably they wouldn't realize that they are participating within the broader spectrum of circular economy themselves. So, and so in some way we could see that the AI has been playing quite a significant role in kickstarting circular economy, and we could characterize somehow them into three broad aspects. One is basically AI has been uh, quite quite a helpful methodology in design and also operations of plants and also processes, and finally optimizing processes as well. So I would say that in terms of design, it's basically about circular designing new circular products or components and materials, which could be we could design it faster and also so that they could be more suitable for circular economy itself. For example, they could be more suitable for recycle and reuse. And if we move to basically design, we would see that the main the three broad aspects here would be basically cutting through the complexity. So how AI has been used to go through multiple designs quickly and to come up with the best design for which could be more suitable for recycle and other stuff. And also the data is something, as Aki mentioned, a lot of data is being collected and a lot more data would be made available. And how do we scan through large databases so that of well-labeled data so that we could create new types of designs from them, and also finally to generate, let's say, novel designs. So I would say the first thing if we go is mainly I would go for the chip design. It's not Motiva, but it's Motivo. Very good. And so it's a San Francisco based a startup company, and it's their main focus is on chip design, and everybody here knows how important has chip become in our everyday life, because I myself have been waiting for like more than 1 year to get my new car. So finally I had to buy something other, gave up the production because of severe chip problems. But in order to even so that means that enough chips are not available, or also there wasn't a chip probably which would be more more recyclable and reusable, so that we could get more of those cars and products up open in the market. So I think it's so in that way, Motivo is a fantastic company, and they use AI for chip design and also transform traditionally lengthy design process. So usually the design process goes for several years, and they are able to cut short the design process. And the platform that they actually use is called Tralfa, and it has helped chip designers to basically when they have their own design, it goes through the design and it suggests new design patterns and also optimize their own process in terms of suggesting what different materials can be used in the chip design, and also what different configurations can be done such that the overall performance and cost could be actually improved. And this recommendation is quite important, and it has been able to help them to change the layout of the chips and also find very different materials from a broader material database to and also new manufacturing processes to actually make such chips. The second would be in the area of metallurgy. So I think in metallurgy, there's an upcoming field of accelerated metallurgy. So there was a project, let's say it's not a company, but let's say the European Space Agency, they had funded in a project on accelerated metallurgy. So it's basically how to use AI to come up with new alloys. And the novel alloys should be non-toxic, designed to be reused, long use periods, and also so that we could use additive manufacturing, used in additive manufacturing. So these are kind of, let's say, very notable points of which could help circular economy, so that the metals are non-toxic, so they can be used for variety of different purposes, not for the purpose in which it was actually meant for, and so that the metal is actually in circulation and reused in different ways. And so in this accelerated metallurgy, So what it does, what we do here is basically we analyze data on properties and the performance of very different metals and alloys, and the AI algorithms comes up with unique combinations of metals, which help us develop alloys which are more sustainable, and they have the design, and at the same time there is no compromise on the desired characteristics of application, because some of these alloys are business critical or engineering critical, so you cannot really have a compromise on the performance. But at the same time, the humans would never have thought certain combinations of metals, or probably it's also not even possible for them to test because it takes money and effort to test, make new alloys, test them, build properties. And European Space Agency, through this program, actually created an end-to-end automatic process. So it automatically collected metals, and they made some spot alloys, and then there was a machine which analyzes the characteristics and uploaded the characteristic to the database. So that was an interesting read, which I would suggest everyone to go through. And yeah, so the third one is probably more profound for everyone. And this is Notco. I think it's a South American based company. So I think it's having oat milk and alternate source of milk is something which everybody is using. So this is more common these days. But how do we come up with more such alternatives of animal products for even not only for human consumption but also for animal consumption and other things? So, and Natco did a fantastic job in developing this platform. I think it's called GUSEP, if I'm not wrong. So what it does is it analyzes the chemical makeup of a variety of plant-based ingredients and uses this information to create plant-based versions of animal products, such as milk, meat, cheese, etc. So by not only it does this, but it also analyzes quite a lot of animal-based products and other similar products, and it tries to analyze their flavor, texture, and nutrition profile. And then it tries to go and look for plant-based products which can give a similar kind of a texture or a similar kind of a flavor. And all this is done online on the computer. So there's less of trial and error, and we could go through multiple design concepts much faster and come up with products more common. So for example, you could use a lot of plant-based derivatives coming from probably construction in this plant forest mills, and how could we use some of those things to kind of manufacture probably even animal-based food nutrients for them. So if we know what kind of product chemical compositions are available, so we could scan them, multiple of them, and create more products of nutrition value. So going from creating those, so if we go to the operate, this is probably one of the most important, where the companies are probably looking to save on money and make their circular economy business model more profitable. So the three most important things which are done these days is basically dynamic pricing, and having better matching algorithms and predictive maintenance. So I think Mikhail initially said Solita has been working in the area of predictive maintenance in Kone, and so this is one of the, let's say, most desired projects coming up for many companies, and this actually creates quite a lot of value. So if we go to dynamic pricing, so this is an American company, so which is in the resale apparel business. So this resale business is really, let's say, I wouldn't say still in the dark ages in quite many places. So you basically, once you have no use, you take it to the nearest trash, or you take it to, or you put it on Facebook for recycle. But it's not that attractive when the people themselves put pictures and how you go and where do you want to give away certain products. But the main reason being that when you go and resell, the resale value is not of so high value for you. So this company tried to change that. So they wanted to provide a hassle-free solution for recycling apparel. So what they did is basically they try to come up with a pricing model based on how the apparel looks and also from where it is coming. And then they try to give an equivalent coupons for them for into more attractive brands to buy first-hand apparel. So basically, there was no money exchange, but there was coupons given to go and buy. So in that way, what they did is that they not only incentivized the main the original manufacturer of of apparels to have more brands that could have a longer shelf value, but also incentivize these people to go and shop, have coupons so that they can go and shop in the main chains. And also they use also used quite a lot of data based methodologies for having sales strategies and also having this kind of a promotions, and a lot of these things are done in this company. And predictive maintenance. So well, of course, I could have told you about Kone, but many things are confidential and things you can read. But I will bring about SKF. But this every company does very similar things. So there is basically nothing very important. I guess everybody knows SKF, quite a Swedish company, uh, mainly in bearings, and they have been able to use prolong their items, or the usage of their items by using predictive maintenance, and that means that there is a increased machine uptime, and there is low maintenance cost. And the most important thing was that they went from more transactional to performance fee based structure. So basically, they would price based on how about the performance of their metals rather than transaction based purchases. So that's what they are experimenting. I'm not sure whether it's actually in use, but that's what the reports said online. So and so they use manual data driven modeling. That means that usually sometimes you don't have that much of data. So you need to combine your physical know-how about the problem or also the physics of the problem and integrated them with the AI and ML so that then you can basically leverage physics to speed up AI ML and also see that it makes sense. And one more thing which was more interesting to me was the using of automated ML there. There, the software itself selects own algorithms there and generates digital models of machines and continuously validates and maintains those models. So all this is automatic according to SKF, but many of these things, I don't know how they actually perform in practice, but some of this work is on development in many companies. So if we go from there to optimize, so that's the optimize the circular infrastructure. And I think that's where Aki was mentioning quite a lot of computer vision. So I would go through mainly in terms of automated assessment, and there is automated disassembly and also sorting. So these are kind of main important areas, but I would pick two of them. The use cases being e-waste recycling. So Refined Technologies Sweden. So they have an intelligent sorting and classification of e-waste. So basically, when the waste comes in, so they have they try to maximize the value from the e-waste by recognizing the condition of the electronic product so that they are sorted based on what kind of condition is coming so that they can easily process and recycle them. And what has been used is more visual recognition and supervised machine learning enabled with technology to sort waste. And of course, it needs quite a lot of manually labeled images to train your AI algorithms, and that is something which needs to be built up. And I guess Zen Robotics doesn't need much of description in Finland, so quite well-known company. And they use AI and with the robotics to recover recyclables from waste. So the main component of circular economy here is waste sorting and enabling operators to assess waste streams to respond to changes in the quality of waste. And thereby they improve recovery rates and quality of outputs. So mainly the AI has a combination of data from cameras and sensors, and then it does its own magic, which is called ZenBrain. And they analyze data from the sensors and provide accurate real-time analysis of the waste stream. And this is very important, probably for quite many waste processing machines and also process industries, because certain waste processing machines would break down if certain inappropriate material is fed into them. And also in process industries, you need to know what is the when, for example, in let's say assume stainless steel manufacture in electric arc furnaces. So it's a common thing that you put metals back to make steel, and if you don't know what's coming into those steel, then probably your desired purity is not achieved at the end. So there's quite a lot of uncertainty of what kind of metal you're finally going to produce. So this kind of a characterization is quite important, and AI is perfectly suitable for such a case. Yeah, so I hope I gave you a glimpse of different aspects of how different applications could be used here. And of course, there are much more. And we are quite happy to discuss with you guys if you have any application where you feel yeah is appropriate or not. So it's a perfectly good time to be in. Thanks.
Thanks, Karthik. Any questions from the live audience, Karthik, at this point? And same applies to online participants. So if any questions, post them to chat now. None from live audience. A question from myself then. Any favorites or this kind of any use case areas which you feel personally most passionate about, either from the ones you've raised or others in this context?
Yeah, I think if you see that, if I see the technology wise, probably predictive maintenance is something which is quite challenging as a researcher and also as a technologist. And of course, every application have their own challenges. And if you ask me from a meaningful societal perspective, I would go for more of this recycling, sorting based things, which you can see the immediate value there, and in creating an impact so that the maximum metals are in the recycle stream, not ending up just in the let's say pyrolysis, just burning, which is the worst possible thing.
Yeah. Thanks. So no further questions, I think. So let's move on the agenda then. Next we have insights from Tana. So Teemu Lintola, welcome.
Thank you. Excellent. Great to be here. As you can see, we have prettier guys at Tana, like Tommy here, and also more intelligent guys, but all of those guys were busy, so sorry that I'm here. I try to do my best. So subject of the presentation is that how AI can play important role in Tana. And here's a little bit about myself. So I have some history from different companies, Ponsse, Outotec, Sandvik, Patria, and all of those companies, it was about big machines and intelligence and digitalization. So same kind of problems, same kind of challenges, treating material, try to optimize what those equipment are doing, try to optimize the life cycle, try to optimize the uptime. So that's the presentation. I'm also having a second role as technology advisor in XT Solutions, so digital defense ecosystem, so involved in that kind of business also. So a little bit about Tana. This is actually a relatively old company, same age as Ponsse, started 50 years ago, manufacturing these kind of landfilling compactors. It's privately owned company, Finnish company based in Jyväskylä. And Tana 1.0 level, what we are saying is a traditional OEM with in-house manufacturing. So Tana was building equipment at Jyväskylä manufacturing facility. Second step for Tana was that, okay, one of the owners bought the whole company and started creating a next step vision that, okay, Tana should be something else than just the traditional OEM building equipment. And idea was that, okay, digitalization has a big role, but also that Tana was started to be a networking company. So having only a key core team managing the operations, fully outsourcing manufacturing, or outsourcing some of the even R&D, and having a dealer network selling and maintaining the products. So that was the step 2. Third step, and also company values there, was our foundation for everything. Just highlighting that where we are at the moment, what we are saying is the TANA 3.0. So equipment OEM, which is managing this value network with information. And what it means in real life is that, okay, we have a small team. This is 50+ million euros operation, fully global, less than 40 people. So we are there in between, and we need to have these IT solution systems fully integrated, also intelligent equipment there on the field, connections to the dealers, connections with the customers, and some kind of integration with external systems. So this is the foundation what we have been building and what we are still building at the moment. We have now new full-blown digital service portal in place, and we are changing now the ERP systems, and plan is that is finalized Q3 this year. So this platform is essential, and the information available and having the information also integrated. So then the next step towards the step 4.0, so it would be somehow self-learning system, not just using human brain, but really utilizing this information, but also utilizing technology such that the system should also learn itself. We don't know fully what it is. We are trying to clarify that to ourselves, and hopefully this AI is also helping us. It seems to be smarter than we are. So as I said, that we are a global company, 30+ dealers covering almost the whole globe, less than 40 people, 50 million euros plus revenue, still a small company end of the day, and this kind of vision what we are having is quite ambitious. There were discussions that KONE is having some solutions and Solita is working with KONE, so we are a little bit smaller company than KONE, but still having these same elements on our agenda. So this is our approach. A little bit still repeating myself. We want to be intelligent equipment provider. That is what we are at the moment. So this is our offering: landfilling equipment and recycling equipment. Of course, this landfilling is going down. Recycling is booming. It's a mega trend at the moment, as also highlighted by Aki and Karpi. We need to have new technology to manage this network, manage this business, be profitable. That's obvious. That is what we are more or less step by step having. This is also essential what we have learned, that company on our size, that okay, we need to use proven technology, widely used platforms, widely used technologies. Like Microsoft Azure, for example, that's a safe choice for this size company. Our idea is to work with selected key partners on these high technology readiness level solutions. So we have key partners. We don't have our own team. We are just coordinating the development. And on these new technologies, new ideas, we want to be involved on ecosystems, working with academia, really understand what is going on. But there we are participating and learning. Somebody else needs to do that part, the research and basically the development of this base technologies. We don't have resources for that. So that's the starting point. A little bit, as I said, that when we are testing things, we are doing pilots and low-cost approach there, and carefully choose what we implement, and what we implement, we then do that thoroughly, but really carefully selecting what we do. Once again, relatively small company. And then I have a couple of case examples. These are quite, how to say, practical. So where AI, machine learning, etc., could have a role in near future. This is what we have been already testing a bit, okay? Kartik, for example, has been involved on customer experience measurement. That, okay, this is a traditional way of doing customer experience measurements, that you are sending these survey questionnaires that, okay, then you get some answers and you might have some understanding and somebody might answering, and usually, okay, those guys who are the happiest, they might answer, and those who have some frustrations, they also answer. But what we want to do is really to have this kind of a real-time customer experience measurement, measuring the equipment uptime, how we are handling the warranty cases, how fast we are reacting on problems, how fast we can deliver spares, also enriching that with some manual inputs, and really having this kind of real-time view on how the customers are feeling in the front line. Where is a need to do some actions, and sharing this information also with our dealers, and then basically handpicking that, okay, these are the areas where we need to improve. And also how to use AI to make this efficiently happen. This is a next step question also for us. Okay, we have been piloting this before, then we realized that, okay, quality of data was not adequate, and okay, we did not have the, how to say, integrated solution, so we needed to spend a lot of time on integrating the data from different sources. But when we have the foundation in place, this should be more realistic. This other example is equipment health. Okay, this was already covered in also in Kartik's presentation. Everybody's doing this, and everybody's working there. So this is the traditional way, obviously, that okay, equipment is showing the alarms, warnings, onboard display, then you have an IoT solution and you will get alarms. And usually what happens here is that, okay, you will get an alarm that, okay, your engine is broken. But you realize that actually already 2 minutes ago, you could easily hear, that, okay, now it's broken, it doesn't turn on anymore. So, okay, valuable, but is this really end of the day that much value? So obvious next step is to have predictiveness there. But how to really implement this on our size company when you have limited amount of equipment, limited amount of resources? So we see that, okay, this is also a hybrid approach, that, okay, you need to collect some data from the equipment, you need to work together with component provider like SKF there, okay, they have a little bit more resources than we have on working, for example, on those bearings. So we are not the ones who could build that predictive bearing maintenance solution. So it's somebody else. And also that, okay, we need to enrich that information manually. So add some service history, okay, some case happenings. If something happens, how we could also assist the system to learn faster and learn more, because amount of data what we are having is not enough. But here, okay, we try to learn, we try to build the systems, but we are a little bit following what the others are doing, because there are bigger players there working in this area who have also ready solutions here. Then it's productivity, which is quite essential, of course, in this kind of solutions also. This was also a little bit discussed that when you're having an equipment and you need to know that, okay, how much it is producing. So this is the traditional solution, that, okay, you have equipment there, then you have a weighing system and you need to calibrate that. Nobody has time to calibrate that, and after a while, nobody really cares. That's a little bit a blunt example, but unfortunately, this is a little bit how it goes in a real life. So what we would like to have is really this is a little bit more futuristic in this kind of equipment. The technology exists as like Kartik was showing, that Zen Robotics, which is actually part of Terex these days, that okay, there's all kind of sensor fusion systems and sorting systems, etc. But how to have feasible, reliable, low-cost solution in this kind of a waste shredder? That is also the key. How to measure the input, different output, quality, quantity, size of material. So there we are basically having some cooperation arrangements and we are following the development and also participating some ecosystems where these, how to say, problems are discussed. But technology exists, but is it feasible in this level in the near future? Interesting to see. The business case is there. The next one is technical support. So traditionally in this kind of business, the challenge is that okay, people are there having their equipment somewhere far away. They have low-skilled people there maintaining the equipment. Remote support might be available, not necessary. And really, the level of maintenance depends on the level of the people who are maintaining the equipment. So this is more or less the real life. And we have remote support solutions and IoT solutions already. Okay, especially in a small company, it's European office hours. If customer equipment is somewhere middle of nowhere via satellite connection, it's a little bit challenging. So here the solution, what we are hopefully planning to have in the near future is this kind of intelligent assistant for guys who are maintaining the equipment, really easy to use, combining the future cases, having some fault-free functionality, collecting data from equipment, hopefully having also connections to wider cloud-based data storages, but really helping the guys there on the equipment even when they don't have full online connection. This would be really valuable. Easy to use, intelligent, reliable solution. Step by step we are building, we are collecting the data. So these are real life case examples where AI and machine learning could be used. Like on this productivity, computer vision, etc. Those technologies exist, but on that level where we are not there yet. But as a summary, couple of learnings and what is our approach. So this is how we identify ourselves, that what are the key drivers. So creating awareness, operational excellence, high fleet uptime, predictiveness, differentiation, creating more business, equity optimization, and easy to work with us. I think quite many companies are having the same. There's nothing special if it's small company, if it's big company. But then more practical learnings that okay, piloting is really essential, but also after the piloting, when you are really developing the solutions, then you need to have a process in place, then you need to have a use cases, test the solutions. Otherwise, you just continue playing with the data and playing with the solutions, and those will be not suitable for real life use. So that is something what we have also learned. This real customer and internal need that needs to be really analyzed and understood. So what is essential, what is valuable, especially for the customer. So we are not building technical solutions because we want to build technical solutions. So there really needs to be a business case for that. Foundation needs to be in place. Also a good learning that okay, you need to have integration, you need to have data, you need to have right quality data on some feasible format such that you don't endlessly play around with fixing the data and understanding what it means and going through the different databases and timestamps and all of that. So having this foundation in place, it's quite essential. And then cooperation with industry and academia, having the right partnering, essential, because these new technologies, it is quite expensive to develop these solutions, and everybody's basically, they are having the same challenges, same problems. So having this cooperation, quite essential. And then there, as a last points, couple of questions that there are a lot of indirect benefits when we are developing these solutions and a lot of ways to improve the internal efficiency, but how to make money? How to directly make money with these new technology solutions. When you are selling this kind of CapEx equipment, 500,000 euros plus, and then, okay, you might sell 100 euros a month service on something, but what could be really these kind of little bit bigger business cases here? This is something what we also try to further analyze. And then skills development, all in all. We have a small company and we have, honestly saying, of course, challenges to understand the technology, understand all the possibilities, especially on the front lines customers. So in this kind of traditional business, and there's more and more new technology, more and more possibilities, how we can develop the skills and then ensure that, okay, people also understand what we are doing. So this is what roughly Tana is at the moment doing. This is how we are thinking as a small equipment OEM working in recycling business, that how this AI could be used in practice in these cases what we have. So if you have any questions, feel free to ask.
Thank you, Teemu. Any questions from the live audience? Teemu, you come a bit here. Yeah. Thanks. None at the moment. Still time to ask questions. You actually a bit stole my questions in the last presentation. I was also thinking about the skill development and like awareness of the potential different new technologies and AI, etc. has. And you had that as a question that yourself, so you might not have answers, but what kind of approaches you have taken? Have you had some kind of a training programs or ways to your compact set of people, 40 people, handling the whole business? So I assume many of them are not like they are born or fully understand all the capabilities or possibilities there are.
That's for sure. We have internal training ongoing. Of course, we try to, and also as a top management, basically to how to say, encourage people that okay, you need to follow the technology and also discuss a lot of about this. Have some e-learning packages, but it's also cooperation and this kind of continuous process. But I think it's in that sense answering that okay, it's a little bit two ways that. Now, what we, for example, quickly discussed with Kartik, that okay, there's this ChatGPT now. Yeah. That okay, people found that hey, here's ChatGPT.
Great, we got ChatGPT also to this event.
Exactly. So now that will that replace our technical support and will that develop our products in the near future? That okay, the ideas might go here or they might go here. Yeah. Two directions in that sense.
Yeah.
Might create this kind of overhype also.
Yeah, exactly. And it's part of this kind of general awareness and knowledge building, but also learning through trial, like being part of the process, of the innovation process. Yeah. Thank you.
Thank you.
There's one question. Yeah.
One question related to the business model. You said that they are not ready to pay for the like the, let's say, predictive maintenance or that kind of stuff. Or this kind of services. What they think that shorter breaks in the production would benefit them, or is the industry so old-fashioned somehow that they don't see the benefits, or what's the reason there is no like a business model yet there for innovations?
Yeah. Could you shortly summarize that?
Yeah,
line
this-
as well? So
Yeah, I can. So question was about business model on these new technologies and features or digital services. So of course there in that sense there is a business model or it is easy to say that okay, this could be the business model, but when you say that okay, that this practical answer to your question to some customer that okay, I will now reduce your downtime by 10%, then the first question from the customer is that okay, could you please show what is my downtime? And then you start building that okay, is it equipment related downtime or is it operator related downtime, and there are so many elements. One summary to that question, the answer to that question is that okay, the challenge is that especially the traditional mobile equipment owners, they don't necessarily exactly know where they are. So that would be the first step to really prove that okay, you are here, and then we can improve that by 25%. And that is also a small challenge in that sense. But answering to that, it is quite traditional end of the day.
good. Thank you for the question, and thanks, Teemu. Then moving on to our last presentation today, Jokke Ruokolainen from Solita, machine learning architect, will be covering the next presentation about AI DevOps lifecycle and using this kind of a case study about industrial waste sorting with AI as an example there.
Thanks, Mikael. So moving on to some a little bit more technical topics. I'll be first presenting this use case that Solita has been working with the customer on a high level that will bring together the need for the last part of the presentation. Why do you need this DevOps lifecycle? We call it MLOps. That's the common term for it because DevOps is originally meant for software development, and when you start building AI and machine learning applications, you need the same principles but with some differences and different approaches. So the use case that Solita has been working with our customer was revolved around hire classification. It's a waste management problem basically. You need to be able to classify summer and winter tires automatically in a conveyor belt system, and that basically influences the throughput of the factory or the recycling plant. So the solution was to build this decision engine using machine learning and AI, and also build the instrumentation so that it can be run directly on the recycling plant floor. And the benefits of the use case were that the throughput of the factory increased while lowering costs. There was less downtime due to complete automatization. So this pre-study phase of the project focused on building a decision basis and to move into actual implementation. There are multiple similar facilities operating within the customer's company, and their first idea or the first phase was to implement this proof of concept. Can this be done with the current equipment? Do they have the data to actually do this? And what would be the actual benefits of this solution? So first month of the project was used just to define what do we want to achieve with this particular use case. Then we agreed with the customer that what are the KPIs basically that we want to measure that define success or fail in this particular project. To build momentum inside the company and spread knowledge that what are we trying to do with the data and how are we going to benefit the business with this particular use case. And 2.5 months of the actual project time was spent building the actual implementation, so that involves the instrumentation and the code itself. And once you reach that phase that you've proven the value that this can be done with machine learning, that the company has the data, you need to be able to deploy the multiple different facilities and to be able to scale the actual system. So how do you get from this concepting and proof of concept phase into actual production and start scaling the business? Is where the DevOps lifecycle comes in. This is just a high-level architecture picture how the system worked. The tire basically goes in the conveyor belt, and there's a sensor input. In this case, it was a camera. The decision engine reads the markings from the camera, for instance, the DOT codes, other markings. But the ones that we were interested in this part, whether it is a summer tire or a winter tire, and it's a little bit tricky problem because each tire manufacturer has their own basically way of printing the same information into the tires. So the approach used here was to actually collect images of the tires, label them, and use object detection algorithm to detect whether or not it is a summer or a winter tire. You can achieve the same results with other techniques, but this was the chosen technique for this project. So the MVP system saw that 928 tires collected in June alone with almost 98% accuracy. The overall accuracy was 97.85%. The summer tire accuracy was a little bit higher because there were more summer tires in the system than actual winter tires. So the KPI for this project was that it would be at least 95% accurate, and it would be able to sort 1,500 tires in an hour. And based on the MVP, the customers decided to scale this inside their business. And that's the part when we come to this DevOps and MLOps, how do you actually operationalize an AI solution like this and start scaling the business and scaling the IT. So the challenges that organizations face usually when they start doing machine learning or AI solutions, when they start or you start doing machine learning solutions, you first have to identify a problem or an opportunity to utilize AI. And you need to understand the business needs and objectives. That do you want to optimize a certain part of the business? And if you do, how do you measure the impact? Once you have that down, then you need to basically solve the need of data. Do you have the data that can be used to solve this particular problem? Can you collect it? And what's the quality of that data? After those initial things have been solved, then it's basically R&D. You have to build, train, and test and validate the machine learning approach with the data that you have available. And then you have to evaluate that solution against unseen data. Does it actually work in a real world scenario? And then you have to deploy the model somewhere. Like in that use case, there was this minimum viable product in a single factory, and you start gather feedback. Basically, does it work? Are there bugs in the system? Do you need to make changes to the instrumentation, for instance? And once you have it deployed, you need to be able to monitor the system, because machine learning models tend to drift. When you train it with a single data set, it doesn't work indefinitely. If the data changes, then the algorithm itself breaks, or the solution might break. A concrete example from COVID times was that Amazon's recommendations algorithms broke because people started searching for hand sanitizers, and that basically shifted the whole data. So the algorithms didn't understand what was going on because there was a massive spike in the hand sanitizer searches, and they started basically recommending sanitizers to everybody. So if you cannot catch that immediately with monitoring, then if you have a business critical system, then it can be quite troublesome. Somebody calls you that, hey, your product is not working, but you're not aware of it yourself. This is a really popular slide in all machine learning and MLOps text, that the hidden technical depths of machine learning solutions. So the actual machine learning models and AI code is that small black box inside the system, and everything else around it is needed and necessary to make it actually operational. So a huge amount of the project time when you deploy solutions is actually used to build that surrounding infrastructure. And of course, when you want to build multiple machine learning and AI solutions over the course of years, you don't want to do that infrastructure over and over again. You need to build it in a manner that it's reusable and scalable and maintainable for other use cases as well. So the key is to use this MLOps framework to unlock the AI operationalization. So DevOps originally was invented to make software development agile, make the code reusable, and make bugs traceable, and have fallback strategies if something fails in production. And it's very similar to that, but AI specific. You need to be able to version the data that you feed to your models. You need to be able to version the models themselves that you're using in your AI solutions. And you need to be able to trace the changes in the solutions. If you feed new data into that model, how does the model output actually change? And it's a crucial part of that life cycle. So when you start scaling the business and IT with machine learning, there's this possibility that you end in this maintenance hell where you actually start doing projects over and over again and building the exact same things that you've previously built in another project, and it becomes unmaintainable, and the development cycles get longer and the deployment cycles get longer over the time because you didn't build the framework in a manner that it's interoperable and collaboration can be done on top of the platform. So if you build a single AI or machine learning solution, you need to build the platform and the infrastructure in a manner that when you start working in the second project, you can take pieces from that original infrastructure into the second project. You don't have to build everything from scratch. So even if the initial first projects take a little bit more time when you're building the platform, you start getting cumulative gains because you start gaining momentum as the platform gets more mature and the information inside the company gets spread among the workforce, and people start understanding that this is how you do machine learning projects or AI solutions, that there's differences compared to some like a common software projects. And MLOps maturity is like a step-by-step journey. You start usually with no MLOps. That would be a data scientist developing the models on their laptops with some Excel, let's say Excel data. No version control for the data or for the code itself. The next part would, next maturity level would be DevOps, that you actually version the code. That's a good start. Next one would be the automated training, where you actually have a training pipeline deployed somewhere that when the training data updates, then that triggers the model training. You can validate the model automatically and monitor the training. Does the model keep improving over time when the new data gets added, or does it start degrading? Then you might have automated model deployment. After that, you have some kind of service running that's being exposed to customers through APIs or through a web page, that if the model gets updated, the customer doesn't notice a thing because the model itself gets updated in the background. And the final level could be that there's automated lifecycle management, that you start reacting to things. Something changes in the data, it automatically starts alerting the right people that you need to come and check the system. Something changes in the model itself, it reacts and tells the data scientist to check the parameters of the model. Or for some reason the front end doesn't answer, and it reacts to that and sends alerts the people responsible for the front end. And you might have advanced fallback strategies at this point, because if you have business critical models, you have a device that's completely automated and for some reason the model doesn't work. Do you shut down the machine, or is there a different fallback strategy? Does it just inform the operator of that machine that, hey, I cannot work automatically, you need to take over and start working manually? But the key here is the focus on impact. There's no point in building this massive MLOps framework from the beginning if you don't need all of the features in the beginning. It usually doesn't lead to good results. So when you build the first solution and the first MVP, you build the MLOps framework features based on the needs of that particular solution. And then you add that at least the monitoring part needs to be added on top of that. But when you start the next project, you should have code versioning, maybe some templated code, how to deploy models on top of that framework and other pieces already available to be used. So more about this monitoring of machine learning systems. It's not just about the performance of the system itself. I've already talked about this drift, that they are a little bit tricky, because if the data changes, that actually changes the model. If the code itself doesn't change at all, the output of that code will change with the data. So you need to be able to monitor what goes in during the training and what comes out during prediction and what comes in during prediction. That leads to better results, and there will be some GDPR related issues with AI in the future. Very similar stuff they will be asking the same stuff. Why did it do this? So you need to be able to backtrack everything that goes in and comes out. And if you continuously strive to a level of performance with the models, you cannot even keep track that are you actually optimizing your business? Is it performing well or bad if you don't monitor these things? If you just deploy something and during the offline evaluation phase or the initial feedback collection phase, it's actually working really good, optimizing your business, and you leave it there and don't monitor it after that, how do you know that it's actually working? It might be degrading over time and start doing damage to the business itself. So the key benefits of machine learning operations: auditability and explainability. You need to be able to audit what comes in and what comes out. How did it impact the model itself, or how did it impact the business itself? If it's a business critical application, you can also explain your models to a point when you know what's going in and what's going out, depending on the algorithm itself. Once you have the framework done and it's working properly, you have a possibility for faster delivery and scalability, because you have a lot of reusable code. You have templated code, you know how to deploy to the system or to that framework. The level of automation is high. perhaps you don't, perhaps the data scientists themselves can at certain point do the deployments. You don't need DevOps engineers or multidisciplinary teams to run projects. The model and result quality is better because you can monitor, you can react to changes, you can automatically tune the systems, you can automatically detect whether the problem is in your AI solution or in the data or somewhere else. And reproducibility and best practices. You have the reproducible code. You can run the projects through in faster time. And also, once you do more projects on top of the platform, you start developing these best practices. How do we do machine learning projects? How do we build AI solutions? There's no single framework that works for all companies. You have to test it, what works for you. Do you do it in an agile manner, or do you have a different approach? Are you more research and development driven? And MLOps is not a pure technical problem. The reality is that organizations face that not all of the data scientists are capable of doing or having a skill set to do either software development or putting things into production. So MLOps frameworks help in that because they aim for a high level of automation, which enables the professionals to do things themselves. You don't need to be a software developer or a front-end developer to be able to deploy things and monitor things. And mostly it's a cultural problem because, well, one thing that was already mentioned, that there is no business model currently in all fields for machine learning products or solutions. It's really easy for manufacturing companies to buy a drill that costs $1 million, but when you say that you need another $1 million to automate, but with software, you don't have anything tangible after that, and the process becomes a lot harder. So when you start your machine learning journey, it's important to first focus on the AI and data strategy. You need to understand the technologies and the aims a little bit better. And when you have that done, you start building the actual solutions, then it's easier to see what kind of specialities you need in those projects. Who are the business owners? Do you have perhaps a separate owner for the AI solutions themselves within the business? And the reality is that you can see from the grid that the AI solutions team or the MLOps framework team, they cannot work in a silo. You always need to expose them to the whole company. The business needs to be directly involved in the projects. And if you're doing instrumentation or you're bringing the software into a machine, then the machine development or the R&D needs to be also involved directly in that project. That's all for me.
Thank you, Jokke. Any questions from the live audience to Jokke about the AI DevOps lifecycle presentation? And same request also for the people online. If not at this point, then there is one.
Hi, Mikael. I have a question from the back, actually not regarding the life cycle, more about the use case.
Sure.
I thought maybe some people online or here today would be interested in understanding what sort of an effort goes into creating a solution like that. So without going into any confidential information, could you maybe provide us with an idea of sort of the scope of the project and the work effort where you're, or whatever?
The work effort for that particular project from scratch to the MVP was roughly 6 months, I would say. That includes the instrumentation and the testing and gathering feedback. And after that, the decision was made that this needs to be productionized, and that involves the phase after that involves the MLOps platform, and it took a little bit longer. I've worked with a similar project for my previous employer. It had some differences with the instrumentation, but the overall time there was also around 6 months. Proof that this can be done with the instrumentation itself. But yeah, it depends a lot on the use case and a lot on if the data is available or not. This kind of a solution where you start taking pictures and annotating the pictures takes a lot more time than collecting something from a sensor directly. So there's like no how should I say? I cannot box everything, but it's always 6 months. It can be longer or shorter depending on the solution and the problem itself.
I can also build on a bit on that. It's highly dependent also on the maturity of the use case, how much concepting there is still be done. It's always cross-functional work to build these solutions. You need business design, service design competencies. You need ML engineering, MLOps skills, data science skills, domain specialists who know really the process, business process, etc. So it depends on where we start. If we are ready to jump into the technical development, then it's much shorter, of course, but that's rarely the case. There's always more to be done also on the other areas. Any other questions? Then I think, thank you for Jokke. We are ready to start wrapping up. That's all the presentations. I hope you found interesting use case examples from Tana, understood a bit more better the circular economy, what we heard from Aki and the problems and possibilities there. In case you are looking for help to build any kind of impactful AI solution and do AI utilization, do not hesitate to contact us on that matter, and happy to also answer any further questions offline then later on if those arise. We'll be sharing the recording and the materials to the participants in coming days. So that being said, thank you for everyone for joining, and I hope you had an informative afternoon.